through 11 here, 9 through 12, I'd really spend some time for you studying these types of problems. Once you get the hang of them, they flow pretty well. Main thing is you need to know the scale factor between two similar polygons. The scale factor here, we can see the scale factor is from left to right, clearly 8 to 3. That fraction reduces, so 8 to 3 there. Main concept is scale factor. If the ratio is A to B for the scale factor, the perimeters have the same ratio and the areas have that ratio squared. So to find the perimeter first, let's do that. It's the exact same thing left to right as 8 to 3. So 8 is to 3, left is to right as 144. 144 here is to the perimeter that we're looking for. So what we're going to do here is we're just going to cross multiply, and after doing so, you'll get your perimeter of 54. The calculation is obviously not difficult, it's understanding that relationship. Calculation is also not difficult for the areas, but we have to use 64 over 9 because the ratio of the areas is the scale factor squared. And we've talked about in class of why that's true. So 64 is to 9 as this time I don't know the area of the left one, so I'm going to take that in the numerator, that's the larger one, is to 180. So when I cross multiply and I solve this, I actually get an area that equals 1,280 units squared. All right? Now that concept down below here, read this question a few times, understand what it's saying, but after you read it a few times, you should realize that the scale factor from small to large is 1 to 3. So that tells you that the ratio of the areas is 1 to 9. Well, what is the area of a regular octagon? 3 times as large. They're asking you for the area of a larger octagon than a given area. So this is the smaller one here. So we have small to big. 1 to 9 is equal to small 35 over the area that we're looking for. So when we cross multiply and do this, we're going to get an area that comes out to 315 centimeters squared. Most common mistake is obviously using 1 to 3 in this proportion, but that's just not true. Read 11 again a few times. Understand that they're basically giving you a scale factor here, and then they're giving you the area of one triangle. We need to find the area of the other one. So again, I'm not using this scale factor because we're doing the ratio of the areas. So that would be 25 is to 16. You know, prime is to not prime, or I guess image is to pre-image. And then they gave you the denominator here. So we're going to have that over 80, since that is triangle ABC, corresponds to side AB there. So the area that we're looking for up top, get this here, the area that I'm looking for is up top, so we're going to cross multiply. And by now, I know you know how to cross multiply. And after we do that, the area here comes out to 125 units squared would be the units on that. All right, moving down to number 12, the last one of this concept we've been trying to get the last few problems here. Number 12, two similar figures, that's the key. Only when they're similar can we do these things. Have areas of 180 and 125. I really hope you spend some time and focus in on this problem because this is one that can definitely mess with our brains a little bit. So what is the ratio of their perimeters? That's the exact same thing as me saying what's the ratio of the scale factors. So right now you need to understand what 180 to 125 represents. You need to clearly understand what that represents. It represents the ratio of the areas. Well, we can still simplify it. There's no problem with simplifying it. When you do so, you simplify and you get it to 36 over 25, which actually is great for this problem because I'm asked for the ratio of the perimeters. So what we're going to do to get that scale factor is we're going to take the square root of both, and we get 6 to 5. Think of it this way. If I gave you this at the beginning and said, what's the ratio of the areas, you would go here. Okay, so it's really going the other way. 6 to 5 is the answer to this problem. Number 13, the circumference of a circle is 84 pi. So basically, I just told you that the diameter of this circle is 84, and the radius of this circle, just so we know, is 42, because pi times diameter. Find the diameter, oh great, okay, find the diameter, find the radius, sure did, and then find the length of an arc 50 degrees. Subtend you have an arc of 50 degrees. So here's the deal, if this is my circle, and I have my central angle here, and this is 50 degrees, so is the central angle. So again, it's the fractional part. You take 50 over 360, that'll give you the fractional part of the circle, multiply that by the entire distance around the circle, which would be 84 pi. And after we simplify this in terms of pi, our answer is going to be 35 pi over 3. If right now you're lost on the how do we reduce and how are we getting to that, just start slicing and dicing. These zeros absolutely cancel in that fraction, they're gone. If you look at the number 84 and 36, take a 2 out of each of them. So this becomes an 18. This becomes a 42. Is there anything else I can take out? Well, you could just keep going with 2's. Remember, that's just a 5 sitting right there now, not a 50. So, all right, take another 2 out. All right, so that gets me down to 9, and that gets me to 21. Oh, wait, I can take a 3 out of each. So now I'm down to 3 here, and I'm to 7 here. And you can see 5 times 7 pi is 35 pi. 3 is 3. So you can do these by hand by simplifying the fractions. But that calculator is helping you a lot with that. All right, next problem. We have a circle being described here. Arc measure here of, sorry about that, of 75 degrees. And then the radius is a length of 15. Find the length, right? Oh, I'm sorry, hold on. Find the radius of a circle if an arc that measures has a length of 15. So I take that back. Finding the radius, this right here has a length of 15. Great problem for you to understand. Degree and length are two different things. All right. Well, to find arc length, what I always do is I say take the arc length. You know, to find the arc length, I'm going to take the fractional part times the circumference, or the circumference times the fractional part. So doing this, we know the arc length is 15, so I'm going to put a 15 on this side this time. So 15 is the arc length. The circumference of the circle, I do not know the circumference of the circle, so I'm just going to say that's pi times diameter, but I am going to multiply that by the fractional part, and that fractional part is 75 over 360. Okay, so when I actually have 75, I'm going to multiply both sides by 360 over 75. Why am I doing this? So that I can get the pi d by itself, just multiplying by the reciprocal of a fraction. Doing this to both sides, I'm going to clean this problem up over here, and we actually get just the number 72, which is fantastic, equals pi times diameter. I am looking for the diameter, so I'm going to divide both sides by pi here. Pi's cancel, and my diameter is equal to 72 divided by pi. When I do that on my calculator, I get a diameter that comes out to approximately 22.9, and when I divide by 2, because the problem is asking for the radius, I get 11.459 when rounded to 3 decimals. So that's my radius for this problem. So a big thing here is get you guys to just keep understanding that if you have a formula, you don't always just plug in here and find that. Sometimes you plug on both sides of the equations, and obviously that gets a little bit more challenging when we do that. All right, last one on this page is number 15. For a circle of radius 4, so I'm going to draw a quick picture. You should have applauded me there because that is an absolute perfect circle when drawing with this pen. Radius of 4, find the arc length and sector area with a central angle of 12. So this is going to be really small portion here. It's 12 degrees. All right, so what do we need to do here? Well, we need to find arc length. So to find arc length, which I'll call AL here, to find L, we need to take the circumference of the circle, which once again, if the radius is 4, then the circumference of that circle is going to be 8 pi, and we're going to multiply by 12 over 360. So simplifying that fraction, we are going to get to 4 pi over 15. All right, so you really got to know, is it setting it up or is it simplifying? Pretty straightforward here. How many times does 12 go into 360? Well, how many times does that go in? And then you'll realize that, well, I'm getting to an answer of 4, so that goes in 30 times. So that's 1 over 30. So 8 pi over 30 reduces to 4 pi over 15. Just use the inspire. We're giving you that tool. All right, I hope you're inspired by that. The sector area, saw here, we're going to say is equal to, same thing, except now we're going to multiply by the area of the circle. And the area of the circle, the area of the circle is going to be 16 pi, pi r squared. But we're still multiplying by the same fractional part, 12 over 360. So when we simplify that, that comes out to 8 pi over 15, and that one would be in feet squared. Okay, so we're covering a nice area of problems here. Thank you. Can't get it to stop.